In this example, we're going to look at section 7.5. Here we have a system of three equations and three unknowns presented in the augmented matrix form that you should be used to by now. But in this application, we're asked to first identify the rank and use that to identify whether there is a solution or multiple solutions to this system, and then solve for that solution or those solutions. So we'll begin with Gaussian elimination applied to this augmented matrix. When we do that, we copy down the first row, and then when going to the next row, we need to perform what row operations? Let's take minus 2 times row 1 and add it to row 2, and that will give us a 0 to start off with, then 0 minus 2 there, then 1 minus 2 times minus 1, or 1 plus 2, and that gives us a 3 there, and then 5 minus 2 times 0, and so we get a 5 there. And then in the last row, what row operations will get rid of that leading minus 1? Well, that'll be row 1 plus row 3. And when we do that, we get a 0, 0, 0, uh-oh. So we don't get a unique solution. What we find is that the rank of A, then, if you just look at the left 3 by 3 in this augmented matrix, so that's the division there. To the left of that, that 3 by 3 has two non-zero rows, so the rank of A is equal to 2. The rank of A tilde is equal to 2, and that tells us, since there are the number of unknowns is equal to 3, so because rank of A is equal to the rank of A tilde, there are solutions. Because 2 is less than 3, it's an infinite number of solutions. So to find those infinite number of solutions, we're going to take the third row, give myself a little space here, we're going to take that third row, and we're going to, sorry, it's the second row, and it tells us that minus 2 times x2 is equal, is equal to 5 minus 3 times x3. We'll divide both sides by minus 2, and we get x2 is equal to minus 5 halves plus 3 halves of x3. Okay, now with that result, we're going to take the first row, and here we just know that, and we're going to solve for x1 in the first row, and x1 will be equal to 0 minus x, sorry, let me fix that up, 0 minus x2 plus x3 and we know what x2 is right up here, and when we insert those together, what we find is that we get a minus 3 halves x3 plus 1 x3, so we get that x1 is equal to 5 halves, and again we get minus 3 halves plus x3, sorry, minus 3 halves x3 plus x3, so that's equal to minus 1 half of x3. And how we would use this is we would use this and this to recognize that we can pick any arbitrary x3 and know what the appropriate values of x1 and x2 are. What that tells us is that we have an infinite number of solutions, and they fall along the line defined by that combination of equations. So there's our solution. or our set of solutions.